Perfect squares, the nice beginning lesson of a new metaphorical video game world. We have conquered the boss, slayed the dragon that was the quadratic formula. If you are still needing to do that assignment, you can work backwards and do that at some point. That will be waiting for you. But right now, we have a nice beginning, easy assignment getting us into this new unit, this new video game world. And we're starting with perfect squares. You will notice for the first time that I attached a little practice problem for the OSAS test. That's the Junior State Assessment that we take every spring. And I'm just going to start giving you a few problems every now and then that help you prepare for that test. And that'll be like a bonus question, number 11, after our first 10 questions here. All right, so perfect squares. What is a perfect square? Well, I have pulled up over here in some notes the first 25 perfect squares. So if we have a number, in this case 1, and we multiply it by itself or we square it, the number that we get is the perfect square. So 1, 4, 9, 16, all the way down to eventually 25 squared is 625. We're going to be using these today, but we're also going to have our Desmos calculator where you could type in something like 5 squared and always just get the answer. Why 5 squared? Well, because that's the kind of problem we're going to do on number 1, where it says, what's 5 squared? You simply just type in 5 times 5. Or if yours says 7 squared, you type in 7 squared. First few, we're just getting in the habit of using our exponent buttons, which are here. Or you can always hit Shift 6 and put a 2 up there. We've got 196. This, compared to the quadratic formula, is like, what? I can do this. Okay. Number 3. Now we're going backwards. We're doing the square root. So if we go back to our perfect squares, it's now going backwards. It's saying if we start with the perfect square, in this case 9, and we take the square root of it, what number do we get? And looking at the left side here, and we see that 3 squared, sure enough, asking ourselves, what number squared is 9? Oh, it's 3, because 3 times 3 is 9. So my answer is just 3. Similarly, I can go back and say 36. Oh, 36 is 6 squared. So the square root of 36 is going to be 6. Some nice starting problems here. Then we get into a little bit of algebra where we're going to be solving for x. And we're going to have to be using our favorite emo acronym. Da-da-da-da-da-da. SADME. SADME. SADME, SADME, SADME. Which means backwards PIMDOS without the P, because there's no parentheses. Subtract and add first, then divide and multiply. And finally, this is super applicable for this lesson, exponents. Exponents are what we're dealing with here. They're the squared in this whole thing. As with any algebra assignment, we have to do the same thing to both sides, and we have to do the opposite of what we're doing. So with adding, we subtracted. With multiplying, we divided. The opposite of squaring something on both sides is to do what we just did. You go backwards and you do the square root. So I need to type in the square root. Square root of my right side number, which is 16. And I get 4. Now, notice what it says here. If multiple solutions exist, separate them with commas. Well, that's because we do have multiple solutions. Why? Well, because 4 squared is indeed 16, but also so is negative 4 squared, because a negative times a negative is a positive, as we reviewed when we were doing foiling and backwards foiling. So I need to put 4 comma negative 4. If you forget the negative 4, you're going to have to redo it because you're going to get partial correct points. So that's starting with the simplest, the one-step algebra equation. Now we move on to a Texas two-stepper, where I need to again use my SADME. All right. I have some addition and subtraction this time. In this case, I'm subtracting 17. We always go away from x because we want to solve for that. So I do the opposite. I got to add 17 to both sides. As always, I recommend writing these out. You could pause and go get some paper if you don't have it. And then we hit the square root. Square root of 100. What number times itself is 100? Well, I could type it in, but let's just go back here. 100 is down there, and that is 10. So 10 comma negative 10. Because negative 10 squared is also 100. Right on, right on, right on. So we had a one step. We had a two step. Here's another two step. A reminder here that if I have this number next to a letter without a plus sign, without a minus sign, nothing else in between, this is what I call the rabbit situation, where they are stuck together and therefore, like rabbits, they are going to multiply. So the opposite of multiplying is dividing. Notice we divide by the negative as well because it's in front of our x, just like our 3. That's going to leave cancellation on the left with just x squared afterwards. And on the right, negative 48 divided by negative 3 is 16. Take the square root of both sides. Square root of 16 we've had already, but if you do not remember, it is 4. And I'm going to leave these notes up here for the rest of this, at least till we get to our bonus state testing problem. So that if you need to find a square root of something, you can just look up here at these notes. And you can still separately have your calculator up if you need to use it. All right. We had the one step. We had the Texas two step. Now we have the Dylan triplet. Shout out, reminder, I'm a triplet. 3-step equation. We're going to have to use the full power of our emo SADME. The full power, because we've got addition and subtraction, in this case minus 61. We've got multiplication and division, in this case multiplying by 5. And then we've got our exponent up there, the 2. All right, let's go in order. First step, subtract and add. So I'm going to add 61 to both sides. I get 5x squared and have that equal 80. And I'm going to put a little check mark here, knowing that I've done this subtract and add step. Now I'm on the dividing and multiplying step. Divide by 5, both sides. X squared still on the left. 80 divided by 5 is, what do you know? Once again, 16. We have done the division and multiplication step. Now we need to do the exponent. Take the square root of 16. I know what that is. I have repeated that a number of times, including very recently on this exact video. It's 4. So now, hit pause if you need these notes. They're gone in 3, 2, 1, gone. 4, comma, negative 4. Tremendous. 2 more and our bonus problem. And we've got 2 more Dylan triplet 3-steppers. Okay. We have our 2x squared on the right. Don't worry, that just means we're going to move everything from right to left this time. We're going to subtract and add the saw part of SADME. 310 minus 68 is 242. Then we divide by 2. 121 is x squared. Now I need to take the square root. Let's check this up here. 121 is 11. Well, make a wish, because 11's coming up. In this case, it's 11, comma, negative 11. Incredible. And the final one. Notice I'm not writing out all the SADME steps one at a time. If you do need those, you can go back a few problems again. Pause like I told you to pause. But for efficiency's sake, since so many of these are using the same methods, I'm just going to write out the work on these last couple. 12x squared is equal to 64 plus 44 is 108. divide by 12. X squared is 9. Square root of 9, another one we've seen so far, is 3. Okay. And boom goes the dynamite. We are ready for our dun 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 dun. Look at this beast. Mine's green. What color is yours? My favorite color is purple. Sometimes this is blue, red, yellow. Could be all sorts of fun colors. It says, enter an answer that correctly fills in the blank. Find the area of the shaded region. Use 3.14 for pi. Round your answer to the nearest hundredth if necessary. Here's what we got going on. We need to find this shaded region. Anytime you need to find a shaded region that's inside one object, like this square, and outside another object, this circle, we need to find the area of the square and subtract the area of what's inside it, the circle. So we find the area of the square minus area of circle. Here's a little review on what these formulas are. You could Google it, but I just will tell you. Area of a circle is length times width of that square, and then we subtract area of the circle, which is pi times radius squared. The radius of a circle is always in the middle of the circle over, or half of your diameter. And if our diameter all the way across is 20, that means our radius is half of that. What's half of 20? That's right, I can hear it out there. It's 10 meters specifically, but we don't really have to worry about the meters for this because they already give us the units are meters squared. We just have to fill in the blank for the number. Okay, length times width minus pi times radius squared. I am going to get rid of these notes so I can use my calculator. You can luckily use both of these, so you can leave these up and hit pause if you want to, and then separately pull up your Desmos calculator. I have to let these go so I can access my calculator again. Thus, they're going away in 3, 2, 1, gone. All right, so length times width of my, let's get rid of this so we don't, there we go. Length times width of my square is 20 times 20, or 20 squared, since each side is 20, minus area of my circle is pi, 3.14, times the radius, so times, remember the radius is half of our diameter, so if that's 20, half of it is 10, squared, do not forget the squared. All right, that will give us a nice even 86 here. Our answer. Now, once you get it, that's it. You could submit your work. You will see, because this is a bonus question, a little extra practice, that it's not formally graded in the same way. So don't worry about it if you see a 0 here, not next to that normal 10. You'll still get your 100 if you get the rest of them right. And I'll prove that to you right now. Dun, 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 dun. 100%. All right, that was it. We'll do another square root assignment next time on estimating square roots when we don't have perfect squares. And we'll have our handy dandy notes for that as well. In the meantime, I hope you have an absolutely fantastic day, week, month, year, really whole life. And this has been your teacher Dylan, wishing you the best. Take care. Much love. Bye-bye.